Okay, welcome to lecture number 3. We're finally making some progress. I hope you're going to start to see the light at the end of the tunnel pretty soon. We are now on microphones. There are several different types of mics. The most common is the dynamic microphone. It is what you see when you go into any high school gym and they're addressing everybody with a mic at the podium or in their handheld. Usually these things look a lot like an ice cream cone. The most common, this little guy is a circle here. The most common have to be the Shure SM series. This would be an SM58 because it's got a pop filter. This little circle here is designed to keep your plosive P's and B's from distorting when you talk into it. So that's what the little windscreen there is. SM58, this one right here is the SM57. It does not have a windscreen. It is more of an instrument mic. So you would see these on saxophones, guitar amps, anything that's not going to make a plosive. So these guys are great for almost everything. Shure is the manufacturer. So if you don't know what a Shure SM57 and SM58 are, Google it, get a better picture than these. You've probably seen them a million times. We will look at them, by the way, in the studio so you can actually get your hands on them. These are not the only dynamic mics. There's a million dynamic mics, but these are the most common. Everybody in the world who is a pro audio person knows what a 58 is and what a 57 is. So again, this one's going to be your vocal mic. This is going to be your instrumental mic. A dynamic mic basically plugs in, does not need phantom power, doesn't need a battery, doesn't need any type of power source. It's kind of like an electric guitar pickup. You know, you just plug it in and play. And that's one of the reasons that they're so popular. They're also fairly cheap. These guys generally are in the ballpark of $100. And even in the recording studio, not just for live, yes, they do rule the world when it comes to live sound reinforcement, but even in the recording studio, these things, especially 57s, get used on snare drums all the time. They get used on guitar amps all the time. There's even a lot of people who are famous for having recorded their vocals with these very inexpensive microphones. So the point here is, these guys can do almost anything, and they'll do it well enough for it to be usable. It's not going to be useless as long as the technique is good. They typically are what we call cardioid pattern. And so the pattern is the way the microphone picks up the sound. Cardioid also can be called unidirectional. That means wherever you point this guy, he is picking up the sound in front of him, and it's called cardioid because it kind of looks like a heart a little bit. You see how it dips in right here? It's kind of an upside down heart. So it's trying to listen this way, and then as you start moving away from the front, you get less and less pickup. This may seem like it's an obvious reality for any microphone, but it's not true for every microphone. In fact, the first microphones listened everywhere as equally as possible. So these guys are designed in this way. In other words, they're trying to reject these sounds, okay? They're rejecting, they're saying, no, I don't want anything that I'm pointed away from. I only want to hear this, and all these other things get less and less and less until, and especially back here at the very back, that's your strongest point of rejection is 180 degrees off axis. So what's the purpose for this pattern? Well, I mean, it makes sense that you might want to only get this one sound source. And so the idea here is that you can isolate your sound source and minimize the bleed coming from other things that may be happening in real time. In a PA system, maybe it's just going to help you get less feedback because the speakers are pumping and you're talking, and if you get too much of the speaker back into your microphone, that's what causes feedback. So arguably, depending on where you put this guy, it can work out really, really well to give you both isolation of your source and also reduce feedback in a live situation. I should also mention that in addition to those two things, just the fact that it's a cardioid pattern is going to have a certain effect on the tonal quality. Cardioid mics have a certain sound. Dynamic mics have a certain sound. And you just have to experiment and get used to the sounds and kind of learn them over time. It will take time before you really start to learn the subtle differences. And these are very subtle differences, but we're trying to learn those. We're trying to get our ears to wake up and hear them. So one other thing that you need to realize is that with any cardioid pattern, not just dynamic mic, but any cardioid pattern at all, you have something called a proximity effect. That means that if you're really close to the microphone, then you're going to get a bass exaggeration. The closer the mic gets to my mouth, the bassier everything gets. Everything gets louder, but the bass gets exponentially louder. And this is true even at like 4 or 5 or 6 inches away. Not as true as if you're a half inch away, but it's still true. And so therefore you've got to be aware of that. You know, you've got to be aware that, and this is not just a singer, this is a guitar amp, this is piano, this is any sound source. If the cardioid mic is very, very, very close, you will get an exaggerated bass. That's part of the proximity effect. Now, maybe you want that. You know, radio DJs love the proximity effect because it makes their voices sound so ridiculously huge. But there may be instances where you absolutely do not want the proximity effect. And in that case, you either need to make sure the microphone is far enough away from the source that you're not getting the proximity effect, or you got to pick a pattern besides cardioid. All right, so our next microphone type is the condenser microphone. And it is different from the dynamic microphone in a couple of ways. First of all, it has a much thinner diaphragm, and it requires phantom power. 48 volt phantom power. Now, the thinner diaphragm means that this microphone is typically considered more sensitive. That means you're going to hear more detail, obviously in whatever you're recording, but also from whatever may be spilling in. So it doesn't reject necessarily other sounds in the room as well as a dynamic mic probably would. You are, however, going to get what people tend to consider to be a better sound. I'm going to put a little asterisk up there. Better? I put the asterisk there because it's certainly subjective. A condenser mic will usually have more high end. Sometimes it'll just sound clearer, or it'll at least have a sound, a very characteristic sound that at first listen would probably make most people say that one's better than the dynamic mic. Again, that's just listening, you know, without context. You're not necessarily listening in the mix. You're just saying, if this was the only thing I was going to hear, then I like the condenser better than the dynamic, probably. Maybe. Maybe not. It really depends on the source. But these guys are much more common for studio vocals. They're much more common for certain acoustic instruments. A lot of times a guitar will be recorded with a condenser microphone. In fact, very rarely will an acoustic guitar be recorded with a dynamic microphone. I would say it's probably 90% of the time, you're going to have a condenser mic on the acoustic guitar because of the upper end and the detail, getting the attack of the pick, getting more, just overall more information about the way that guitar sounds. As far as vocals go, people love condenser mics in the studio, especially tube condenser mics, because of the extra flattery that you get. There's a lot of color, not necessarily truth, but better than truth. There's a lot of color, and certain microphones may match very well with certain people's voices. And so some people know for sure that they want a certain type of microphone because they've used it before, they know what it does to their voice, and they know that that's what they want. So these guys are going to get used on everything that a dynamic mic gets used on, but they're much more common on vocals and acoustic guitar, and any type of acoustic instrument, really. In a recording setting, the condenser is usually the king. One of the interesting things about a condenser is it has lots of different patterns. It can. Some condensers only have one pattern. Some have switchable patterns. So you still have the same cardioid pattern option, which kind of looks like that upside down heart. In other words, it's directional. It's listening that way. Some are omnidirectional. In other words, they are listening everywhere. You put that mic right there and it's listening everywhere. Now, it still matters how close the microphone is, because if I put the microphone, right next to a singer who's here, it's going to hear that singer way better than it hears the guitar player who's back here. So the proximity is still significant. Now, an omni pattern, let's say I've got a switchable microphone and it has a switch for cardioid, omni, and figure 8. If I switch to cardioid, I'll still have that proximity effect that we talked about earlier, where you get the bass, exaggerated bass response if it's close. But omni does not have a proximity effect. So with the flip of a switch, I can turn my microphone to an omni pattern, and I can put that thing as close as I want to any source, and the very, very near proximity will not have an effect on how much the bass comes through. That's super useful because you're being able to control how much bass you don't get, even though you can be as close as you want. So don't be too afraid of the omni pattern. Just because it is listening everywhere doesn't mean that you can't still isolate the sound. You can still put it very, very close to a sound source, and if that sound source is loud enough and the other sounds in the room are far enough away or quiet enough, then you can still isolate your sound. You don't have to always use the cardioid pattern just to isolate sound. There are good reasons to use the omni. The other interesting thing about the omni pattern is that the sound that does bleed in, like let's say this is the source that you want right here. If you do get some extra bleed from other things that sneaks in from other places, that extra bleed is going to sound more natural because of the omni pattern than it would with the cardioid. The bleed that comes into a cardioid is going to be dull and muddy and sound pretty bad. A lot of the time, the bleed that comes into an omni actually sounds pretty good. And unless you've got an actual problem where you have to you want to fix a note, you've got to re-record something, then that's going to be an issue. But as long as that's not the case, you may actually really like what the bleed does. It might add some three-dimensionality. It might add some shine that you weren't going to have otherwise. So I'm a big fan of omni. A lot of other people are too. And lastly, figure 8 is a pattern that is almost like cardioid on steroids. It is the tightest pattern, but it goes both forward and backward. So it listens this way, and it rejects things to the side much more strongly than cardioid rejects to the back. Now, this can be very useful. It can also get you into trouble really quickly. For instance, because the pattern is so tight, if a vocalist is trying to use a figure 8 pattern and they are moving back and forth as they sing, then that could cause really significant dips in volume just because the pattern is so tight. And as they move off to the side, you drop them. Obviously, you're going to be picking up whatever's behind you, which could be good if you want that ambience. And it may actually be great to reject things to the side, because if you're recording a static source, like let's say a piano, but you've got a drummer over here, then as long as, the piano's not going to wander around like a singer is, neither are the drums. So if I get this set right, I might be able to really do a good job of rejecting the drums, even though they're fairly close to the piano. So all these patterns have uses as far as what they're picking up, but they also have sonic differences. So one mic that has all three of these patterns, you might feel like it doesn't sound very good in cardioid, but when you flip it to Omni, suddenly it sounds a little better. So you want to experiment. Don't just box yourself in based on what you're afraid of the bleed coming in, or if you're afraid of not having enough isolation. That's a valid concern, but you still want to be open-minded enough to see if pattern 1, pattern 2, or pattern 3 actually sounds better on your source. It might be that your source sounds so much better in Omni that you're willing to live with a little bit of bleed through. So we're still talking about condenser microphones. I want to tell you what an SDC is versus an LDC. This is fairly simple. SDC stands for small diaphragm condenser. These guys are usually pencil-shaped microphones that look kind of like a SM58 or SM57, but they're probably even smaller. And they have a very small diaphragm, and they usually point in the way that you would expect them to point. This is, maybe the microphone clip is right here, and so forth. A small diaphragm condenser is typically used for any source that you want to get with great accuracy. Now that sounds like everything, right? But it's not. Usually you'll see these guys on guitars, acoustic guitar, maybe violin, stuff like that. Of course, these guys work great to get like an entire band or choir. You could put 2 of these up and put them 20 feet away, 30 feet away in a big room, and get a really great recording of a wind band or an orchestra or a choir. The SDC are the go-to mics for that type of thing as well. They just sound very, very real. A large diaphragm condenser is usually what we call side address, and that means that it's a bigger mic, first of all. That kind of looks like an SM58, but it's not supposed to. You actually sing into this part right here. This is not pointing up, but I'm looking straight at it, and as a singer, I'd be singing into it like this, not like that. Let me try to draw a different one. Like let's do this from the side. Okay. And so the singer person, here's my singer person, hey, he sings into it this way. That is side address. And this thing is bigger, okay? I mean, this thing literally is the size of my mouth. A large diaphragm condenser is very common on vocals because it tends to color the sound. It is not particularly accurate or real the way a small diaphragm condenser is. So SDC is small diaphragm, LDC is large diaphragm. The LDC is what we usually think of when we think about a recording microphone. Those are the ones that you see up over drum kits, and they're really big. Let's put down here drums. although small diaphragms will be used for drums as well. The difference is the LDC has some type of color. And so it's not enough just to say, well, I want some kind of color. You've got to understand what that color is. You have to know what it sounds like. You have to know what your source sounds like. And you need to have a good idea of why you want that color on that source. That being said, LDC is where the color comes from usually, especially if this guy is a tube mic, because a tube mic is going to give you harmonics, exaggerated, distorted, slightly distorted harmonics, and people tend to love that for vocals, for some type of vocals. Again, SDC and LDC are just terms that you'll be expected to know. Somebody may say, go set up an LDC in this room. And that could be anything from, there are some of the ones that we have, for instance, we have an AKG 414, that's an LDC. We have an M-Audio Sputnik. We have an Audio-Technica 2020, which is a really cheap one. It's like 99 bucks. These are all large diaphragm condensers. Our small diaphragm condensers, we have Neumann KM184. We have the SE Electronics RN17s. We have some Avenson STO2s. So whenever I would go pick something out, generally speaking, I'm not going to use an SDC for a vocal. I'm going to probably use one of the LDCs for a vocal. Now, I have used LDCs on guitar before, but it's more common to use an SDC. All of these guys are going to work to record a choir or an orchestra. I might try to use the AKG 414s for that, but I would never use the Sputnik or the AT 2020 for that. So in general, even though we never have hard and fast rules, in a general sense, most of the time, the SDC stuff is going to work when you want something to sound very, very, very accurate, and the LDC stuff is going to work when you want to bring some color to something. LDCs tend to do better a little closer up. SDCs can work great close or far, as long as you're not afraid of what stuff really sounds like.